This is revision 2 of the generic robot control board. Over here we have the battery input that can handle up to a 30 volt DC maximum. There's reverse voltage protection as well as a step down converter to take that voltage down to the 3.3 volts needed for logic on the board. That power is passed over here to a switch pad where an external switch is wired to be the main power cutoff to the rest of the board. And then we also have a voltage output pad here, which is basically in parallel to the battery input. So if you need any high current output for ESCs, that is where you would attach those. Over here we have the ESP32 C3 Mini. This board has all of the pads underneath, so it's a very small form factor. Over here we have the built-in PCB antenna for Bluetooth in my use case, but it can also support Wi-Fi and a few other protocols. We also have the USB micro connector here for programming the board and communication. There's a UART header here that I have not used, but it could be used if needed. Back here there's also a tactile switch that can be used for changing modes on the board or whatever the user would like to program. Then over here in the top right we have two brushed motor drivers, DRV8871. These are H-bridge motor drivers that can drive the motors forward, backward, and have a maximum set voltage of 2 amps here. Then down here we have two 3-pin outputs. There's ground, 3.3 volt, and then a signal pin. So this can be used if you need communication to an ESC, or if you're breaking out to another module that needs power as well as a signal line. We have large capacitors here to supply current to the motor drivers, and then a RGB LED down here, as well as a just a normal blue LED in series with that. So that's an overview of the board, and then I have it built into one of my new robots over here. So you see I have power going in from my 3-cell LiPo battery right into the corner down here. And then I have a switch connection that comes out of here, runs through the chassis, and then I have a little PCB that just has two broken contacts that are joined by this screw being tightened down. So I can come in here, tighten this, and actually I'll demonstrate that. So I'm able to come in here, tighten that. And it's a easy, reliable way to make and break power to your robot without having to take the assembly apart. Then over here I have power going over here to my little ESC in the corner, and then communication, just a PWM signal to that ESC, is going over here. So it gets the 3-cell power from the LiPo as well as signal, and then that drives my brushless motor up here. And then I have two N20 drive motors, and these are way underrated for the actual power output. I believe they draw 80 milliamps nominal, and this can support up to 2 amps and even higher if you alter the resistor that's on the board. So that will drive both of these motors independently through that connection. I can program the board by plugging in right there and flashing new firmware. And I have the option to add additional boards or inputs if I'd like. If I wanted to add an accelerometer board, I could tie into that, or these other headers down here and build onto this board, but so far it does everything I need. Looking forward to providing more information on the board as well as schematics and designs, and appreciate any questions or feedback. Thank you.